10.4 notes, polar coordinate graphs, page 7. And so now we are on example 9, the lemniscate. So this is a polar curve that resembles the infinity symbol or an 8. It's always centered at the pole, so it is going to be symmetrical by definition. I want you to take a look at how this is generated though. R squared equals a squared cosine 2 theta, and r squared equals a squared cosine, or sorry, sine 2 theta, which causes some problems for us. First off, we've got that double angle to work with, which means we need to keep in mind that if I'm plugging in theta equals pi over 4, 2 times pi over 4 is pi over 2, and I'm really evaluating that cosine at pi over 2. Also, because this is set equal to r squared, we are going to have those instances where we get a value on the right-hand side that's negative, and those are going to be angles that we can't even use. So this is going to move a little slower. I will tell you that when I went through the homework, I do not believe that I had to generate one of these. You do want to know, though, what these graphs look like as you see the different things going on. Okay, so symmetry. This tells me right up here that my A, we're going to graph r squared equals 4 cosine 2 theta. And this is telling me that this is going to be symmetric with respect to the pole, the polar axis, and the line theta equals pi over 2. So I am not going to check for symmetry. I'm going to assume that they are not pulling my leg, and we're going to go from there. So I want to figure out what this looks like. Okay, so I am going to go ahead and create, let's go this way, and I may need to do multiple columns. And so I'm going to go theta, I'm going to go r squared, and then I'm going to put a separate one here for r. Definitely don't want to have to try to do too much in my head. The more that I can write out, the better I am going to be. So when, and maybe let us give a little more room. That should work. So I'm going to start with theta is 0, which is not too bad. R squared equals 4 times cosine of 2 times 0 is still 0, but that's 1. And now I'm going to square root that. And I'm going to get positive or negative square root of 2. Okay. Throw in pi over 12 just to see, because when I double that, I get pi over 6. And so then I've got r squared equals 4 times the cosine of pi over 6, which gives me square root of 3 over 2. I'm going to move this out a little more just so I can keep track of everything. 4 square roots of 3 over 2. So square root of 2 square roots of 3, which I don't even want to deal with, so I'm just going to leave that one at that point. Pi over 6, I get r squared equals 4 times the cosine. 2 times pi over 6 is a pi over 3. Cosine at pi over 3 is 1/2. 4 times 1/2 is 2. And so I take the square root of that. I get plus or minus square roots of 2. I can try, let's see what would be next. Pi over 4. Let's do that. R squared equals 4 times the cosine of pi over 2. At that point it's 0. So I get 0. And that's not bad. Pi over 3, I double that. I get cosine of 2 pi over 3, which is 4 times negative 1/2 negative square root of negative 2. So I can't even take the square root of that. So I can't even use that value, that pi over 3. And what can we do next? Pi over 2? So 4 times the cosine of pi, negative 4. I cannot take the square root of that either. So I've got stuff that's not looking incredibly pleasant. Let's see, square root of 2 is roughly 1.414. So at this point, I've got 0. I'm at positive 2. Or negative 2, we'll come to that in a minute. Pi over 6, I'm roughly 1.4. What's going on? Okay. And at, what else did we have? Pi over 4, I'm back at 0. So I get this much. Awesome. Okay, so let's keep going. Um, 2 pi over 3. Let's try that. I get 4 times cosine of 4 pi over 3. Cosine of 4 pi over 3 is negative 1/2. This is a negative 2, which I can't use. 3 pi over 4. Sorry, wrong place. 3 pi over 4. When I double that, I get 6 pi over 4, 3 pi over 2. Cosine at 3 pi over 2 is 0. So at 3 pi over 4, I'm back at 0, but I don't really have any idea what happened between there. And so I can go to, what do we want to try? 5 pi over 6, that looks reasonable. I get 4 times cosine 10 pi over 6, which is 5 pi over 3, which is a positive 1/2. 4 times 1/2 is 2, and so I'm back at square root of 2. And then pi, this gets us halfway around. 4 times the cosine of 2 pi, which is 1, gives me a 4, and I'm back at plus or minus 2. Okay, so at 5 pi over 6, so let's go this way. At pi, I'm at 2, 1, 2. At 5 pi over 6, we're at square root of 2, so there's, and then at 3 pi over 4, we are back. So I know that this is symmetric across the polar axis, the pole, and the line theta equals pi over 2. So we get this figure 8 centered at the pole, which reflects across both the horizontal axis and the vertical axis. Okay, and here's the issue with the lemniscates. It's not a whole lot of fun as you're going through to keep track of which of those angles you can use, which of those angles you cannot. We definitely want to see the relationships though. So take a look at the bottom. We just graphed something that looks like this first one. Okay, we've got a squared cosine 2 theta. Awesome. Take a look at this second one, r squared equals negative a squared cosine 2 theta. We are going to be able to use for that one all of the values that we could not use up top because we can't take the square root of a negative number. Okay, so that negative out front is going to cancel the negative before we square root. It's going to end up being positive, and so we get this vertical orientation instead of horizontal. Last two are what happens when we're looking at sines. So let's see if we can graph B real quick. R squared equals negative 25 sine 2 theta. And yeah, that looks like fun. So let's see what we can do here. Again, really important to be able to keep track of everything that you are plugging in, because it is really easy on these to get confused, get things out of order. Okay. Notice something else up top here, though. Our r squared equals a squared. Our a squared is 2. Sorry, our a squared is 4, which means a is 2. Notice that that is the distance away from the origin that we went up here. Okay. So what are we going to plug in first? 0. Sure. Negative 25. Sine of 2 times 0 is still 0. Sine of 0 is 0. Okay. So I get a 0. Pi over 6. I got negative 25. Sine of 2 pi over 6 is pi over 3. Sine of pi over 3 is positive 1/2, so this gives me a negative 25 over 2. That's not going to work. Let's try pi over 4. 2 times pi over 4 is pi over 2, so I've got negative 25 times the sine of pi over 2, which is 1. Sorry, try to write and talk at the same time. Which gives me a negative 25, so I can't use pi over 4. Try pi over 3. Negative 25 times the sine of 2 pi over 3, which is the same as what we had above. Negative 25 over 2, can't use that either. It's super fabulous. 5 pi over 6, negative 25 sine times positive 1/2, or sorry, sine of 5 pi over 6, which is positive 1/2. See, I can't write and think at the same time. 2 times 5 pi over 6. I got 5 pi over 3. Sine of 5 pi over 3 is negative 1/2. And so I get positive 25 over... I'm going to start this one over. Okay. So 5 pi over 6 times 2 gives me 10 pi over 6, which is where the 5 pi over 3 came from. The sine at 5 pi over 3, which is in quadrant 4, is still negative. So I got negative 25 times negative square root of 3 over 2. So I end up with positive 25 square roots of 3 over 2. Roughly 4.653. Did I skip one? I skipped 2 pi over 3. What the heck? 2 pi over 3. Which, okay. Negative 25 times the sine. When we double that, we get 4 pi over 3. Since that's in the third quadrant, the sine's going to be negative, so we've got a negative times a negative, which is a positive. 25 square roots of 3 over 2, which is roughly 4.653. And then let's hit pi and just wrap this up, negative 25 times the sine of 2 pi, which is 0. So I'm back at 0. So let's plot that and see where we are going to go from there. So I have got 0, 0. And I can't use anything. Can I use? I just skipped right over pi over 2. Yeah. See, if theta is pi over 2, it's the sine of pi, which is 0. So awesome. Back at 0. Okay, so let's go 2 pi over 3. 1, 2, 3, 4.6. And then at 5 pi over 6, I'm at the same place, 4.653. So I kind of want to see what's happening in between them. I'm going to try 3 pi over 4. And so when theta is 3 pi over 4, my r squared is negative 25 times the sine of 3 pi over 2, which is negative 1, which means I get a positive 25, super straight line there. And when I take the square root of that, I get 5. So at 3 pi over 4, we are right here at 5. So our graph, this half, looks like this. Okay, now rather than cranking out more values and having you sit here and watch me, we're going to use the fact that this is symmetric about the pole, which means that when I plug in 5 pi over 3, I'm going to get that 4.653. Same thing when I plug in 11 pi over 6. And then halfway between them at 7 pi over 4, I'm going to get pi. And there we have our lemniscate in terms of a squared sine 2 theta. Negative a squared sine 2 theta.